I'm going to evaluate the integral of 3x minus y dx plus x plus 5y dy along the closed curve C in the positive direction, where C is the curve x squared plus y squared is equal to 1. So we have that integral there. And to evaluate this integral, I'm going to use Green's theorem. Green's theorem states that if C is a piecewise smooth, simple closed curve bounding the region R, P, Q, partial derivative of P with respect to Y, partial derivative of Q with respect to X are continuous on the region R, and then the integral along the closed curve C in the positive direction of P dx plus Q dy is equals to the double integral over the region R over the partial derivative of Q with respect to X minus the partial derivative of P with respect to Y. So if we look at the p dx here and compare with what we have in our integral here, we see that our p is equals to 3x minus y. And then if we go on and look at the next part, the q dy, then in our integral we have x plus 5 dy. So by comparison there, we see that q is equals to x plus 5y. Then go on and evaluate the partial derivatives. The partial derivative of p with respect to y is equals to minus 1. The partial derivative of q with respect to x is equals to 1. Now the next step is to now substitute these values that we've just obtained. We put them here so that we obtain the double integral over the region R of 1 minus 1. Then that will give us a 2 there. So we'll have the double integral over the region R of 2. And 2 is a constant. We can factor it out. So we have 2 multiplied by the double integral over the region R. So that's the integral that we have now. But if we look at this part where we have the double integral over the region R dA, that is the area of the region R. So from the curve that we are having here, x squared plus y squared is equals to 1. We see that R is the area of a circle with a radius 1. But if you still recall, if we have a circle with radius r, then the area is pi r squared. But in this case, we are saying our radius is 1. So our area will be pi times 1 squared. So this integral here then becomes 2 times pi times 1 squared. 1 squared is a 1, so it will give us a 2 pi. So that's the solution there for the line integral.